Hello learners, welcome to yet another practical physics class. My name is bi-convex Samuel. I am a teacher of physics. In this class, we are going to demonstrate an experiment to determine the focal length of a biconvex lens. We have a biconvex lens here, which we shall put in a lens holder. So we are going to have a screen on which our image will be formed. Our object is going to be an illuminated object. In this case, we have a wire gauze there, which we are going to illuminate. We are going to shine light on it using a bulb. So when we switch on the bulb, we are going to have light illuminating the wire gauze. So the wire gauze is acting as our illuminated object. So we are going to use the lens formula. The lens formula will require us to have an object distance and then an image distance. And when we put that into the formula, we shall be able to calculate the focal length. So we are going to put the lens at a distance of 15 centimeters. So we have our lens in the lens holder, and we have put the lens at a distance of 15 centimeters. So that is our object distance. We then get our screen and we move the screen on the other side until we get a sharp image of the illuminated object. In this case, we need to see sharp image of the wire gauze. So there we go. When we pass that point, we shall have the wire gauze, but it is not very sharp. As we move closer here, we shall reach a point where we have the sharpest image. So we shall be able to measure the distance. We need to have our image very sharp. So the image distance in this case is 30 centimeters. With our sharp image located, we measure the distance between the lens and the position of the screen, and that distance is 30 centimeters. So the image distance from the lens is 30 centimeters. Here is a diagram which is illustrating what we have just done practically. Here we have our illuminated object in form of a wire gauze. We have our lens, and we had our object distance as 15 centimeters. And when we adjusted our screen, we were able to find our image at a distance of 30 centimeters from the lens. Now we go on to use the lens formula. 1 over f is equal to 1 over u plus 1 over v, where v is the image distance and u is the object distance. So we substitute the values of u and v, and when we carry out that calculation, we find that the focal length is 10 centimeters. Therefore, the focal length of the lens that we have just used in our experiment is 10 centimeters.